Hello, future doctors. How are you? I hope your preparation is going very well. And in the previous lectures, we have already discussed all the PYQs from 1988 to 2000 question till 2000. And in the next part, this is our lecture number second of a thermal properties of matter. In this lecture, we are going to discuss all the PYQs from 2001 to 2011. And in this lecture, we are going to cover all the topics related to thermal properties of matter, like thermal expansion of solid, liquid, and gases, and then calorimetry, and then after that, thermal radiation and conduction. So I hope that you enjoying my lectures and you are feeling good. If you have any doubts coming, that we can discuss them, and if any approach of my solving you are not comfortable, or if you have a more approach regarding any question, you can also comments, so that we can give more idea regarding that. So I hope I started this lecture. This lecture is our second lecture of a thermal properties of matter. So this question is the first question from 2001, and in this question what they are saying, that a cylindrical rod having a temperature T1 and T2 at its ends, means first we make the diagram of it. This is cylinder having a temperature T1 and T2. T1 and T2 at its end, the rate of flow of heat Q1 calorie per second if the linear dimension are doubled, means, and then the rate of flow of heat, means initially the rate of flow of heat is Q1. If the linear dimension is double, means we know dq by dt, that is equal to Ka delta theta by L. So this is our formula for rate of flow of heat. And the linear dimension, you know, area is pi r square. So linear dimension they are saying, so double, means R2 is equal to 2 times R1. The length become 2 times initial one. So we can say that rate of flow of heat is directly proportional to radius square and inversely proportional to thickness, right? So we can say that dq by dt for second is equal to dq by dt for first, that is equal to R2 by R1 whole square into L1 by L2. So this comes out to be R2 is 2 times R1 divided by R1 whole square, and length is 2 times. This is L1, and length become 2 times L1. So I cancel out this, become 4 into 1 by 2. And you know that dq by dt they are asking, and dq1 I send here, this is they have given q, so this comes out to be 2q. So dq by dt, when the linear dimension become double, so this become 2q1. So which option B is correct. So option B is correct. So I proceed for the next question. This question, the beam displacement law relation. So this wind displacement law, what they are saying, that lambda maximum is inversely proportional to temperature. So lambda maximum is equal to V by T. So wavelength corresponding to maximum energy and temperature. So option radiant energy and wavelength, temperature and wavelength, color of light with the temperature. So wavelength corresponding to maximum energy and temperature. So option A is correct. Now I proceed for the next question. This question from 2002. Which of the following is the best close to an ideal black body? So ideal black body, black lamp cavity maintained at constant temperature. Platinum black, a lump of charcoal heated to a high temperature. So cavity maintained at constant temperature. This is the most ideal, best close to ideal body. Now I proceed for the next question. Consider two ends of a same length and different specific heats, S1 and S2. Conductivity is K1, K2. Area of cross section A1 and A2. having a temperature T1 and T2 at their ends if the rate of flow of heat due to conduction is equal. Means suppose this is a one rod, this is another rod, another rod, another rod having a same length, means L1 and L2. So if I define this, so this is L1 is equal to L2, having different specific heat and conductivity K1, having conductivity K1 and K2, and area of cross section A1, A2, right? And their temperature difference, having both having a temperature difference, means T1, T2, T1, T2, means temperature difference is also same. And rate of flow of heat for both rods dq1 by dt for first is equal to dq by dt for second, that is equal to k1 a1 delta theta by l1. This is theta 1 theta 2 delta theta 1 k2 a2 delta theta by l2. So l1 cancel, delta theta 1 cancel. So this comes out to be relation k1 a1 that is equal to k2 a2. So which option? Option A is correct. Option A is correct. So I proceed for the next question. For a black body at a temperature of 726 Kelvin. So this is a black body at a temperature of 1000 Kelvin. 1000 Kelvin. Radiating power is 60 watt. And the temperature of surrounding is this is 227 degree, means 500 Kelvin. If the temperature of a black body is changed, means their temperature is changed to T2, they have given you 1227, means 1500 Kelvin. Then the power is what? Then in this condition, what is their power? We know that energy is equal to sigma temperature of core minus temperature of body minus temperature of surrounding, right? So this is E2 dash minus E1, that is equal to, I say this is power. Let this is, if I say power, so sigma A or also come. So this is P2 by P1. And if they take the ratio of sigma to sigma and area are same, so they're going to be cancelled. So temperature of body minus temperature of surrounding for second body minus temperature of body minus temperature of surrounding की power 4 for first. So that is equal to temperature of body is how much? 1000 Kelvin, means 10 की power 3 की power 4 minus temperature of surrounding 5 into 10 की power 2 की power 4 divided by temperature of body, they change it to 1500 Kelvin, means 15 into 10 की power 2 की power 4 minus temperature of surrounding 5 into 10 की power 2 की power 4. So P2 that is equal to P1 60. So 10 की power 14, 10 की power 12 minus 5 5 जा 25, 25 5 जा 125, 625 into 10 की power 8, and this comes out to be 15 into 15 into 15 into 15. So this comes out to be 50625 into 10 की power 8 minus 5 5 जा 25, 25 जा 125, 125, 625 into 10 की power 8. So I say 10 की power 8 if I take common, so this reach 10,000 minus 625 divided by 10 की power 8 if I take common. So this comes out to be 50625 minus 625. So I say this is P2, 10 की power 8, 10 की power 8 cancel, P2 by 60, that is equal to, so if I subtract 50625 minus 625, so this comes out to be 50,000 minus 10,000 minus 625. So this is 9375. So if I send this 60 that side, so this comes out to be, if I cancel 0 to 0, 9375 into 6 divided by 5000. So 9375 into 6 divided by 5000. So this comes out to be 11.25. Something I think wrong is going to happen. Oh, this is for second body. So second body just inverse of it. Sorry. Actually, we have put this for first body. So just don't worry about it. Just what we have to do, just this is for second body. All these calculations, just inverse of it. Means this is 50,000, means 5,000 divided by 9375 into 6. Just, so I think we have done wrong calculation. Just 1 minute. We can rectify them. This is not a problem. So this is 15 into 4. Just 1 minute. So just what we have to do, just interchange numerator become denominator and denominator become numerator. Just 5,625 minus 625 into 10 की power 8. So this is 10,000 minus 625 into 10 की power 8. So this comes out to be 50,000 divided by 10,000 minus 625. So 9375. So if I write this P2 is equal to 50,000 divided by 9375 into 60. 50,000 divided by 60 divided by 9375. So this comes out to be 320 watt. This comes out to be 320 watt. So actually the mistake, you understand what the mistake I do? So just I can explain again. For a black body at a temperature of 320 Kelvin, its radiating power is 60 watt. The temperature of surrounding is 220 degrees Celsius. If the temperature of a body changes to 1227 degrees Celsius, its radiating power is, means they are asking P2. T1 they have given you, and temperature of surrounding they have given you, and T2 they have given you. So what I do, P2 by power, you know, sigma A T की power, temperature of body minus temperature of surrounding. So what I do, P2 by P1 is equal to temperature of body की power 4 minus temperature of surrounding for second body divided by first body. And then after that I put all the values, and then I got 320 watt. So 320 watt is option B is correct. Option B is correct. So I proceed for the next question. Unit of Stephen constant is Stephen constant. So you know power is equal to sigma A T की power 4. So sigma is Stephen constant. So sigma is equal to power upon A T की power 4. Power unit is watt. Area unit is meter square. Kelvin की power 4. So watt meter square Kelvin की power 4. So option D is correct. Option D is correct. Now I proceed for the next question. Consider a compound slab consisting of two different materials having equal thickness and equal thickness. Consider a compound slab consisting of two different materials having equal thickness and thermal conductivity K and 2K respectively. The equivalent thermal conductivity of the slab is, consider a compound slab consisting of two different materials, means there is two slab. Just I make the, it is like this, and it is also like this. Consider compound slab consisting of two different materials having equal thickness and conductivity K and 2K respectively. Equal thickness means L1 is equal to L2. Then they are asking equivalent conductivities, mean K equivalent they are asking. Right? Consider compound slab of consisting of two different materials having equal thickness and thermal conductivity K and 2K. The equivalent thermal conductivity of this. We need to know that rate of flow of heat for equivalent is equal to rate of flow of heat for first, rate of flow of heat for second. That is equal to Ka. Ka. So here you see that I just revise the concept. dq by dt is equal to Ka delta theta by L. So dq by dt is equal to delta theta, that is L by Ka. So delta theta by R equivalent. So resistance, thermal resistance is L upon Ka. L upon Ka. And they are connected in series. So series R equivalent is equal to R1 plus R2. So R equivalent is, the total length are same, is 2L upon K equivalent into area, that is equal to L upon Ka plus L upon 2Ka, right? So L A. So 2 upon K equivalent is equal to 1 upon K plus 1 upon 2K. So 2 upon K equivalent is equal to 2K, 2 plus 1. So this comes out to be K equivalent is equal to, just 1 minute. So this I can write 2 upon K equivalent is equal to 3 upon 2K. So K equivalent is comes out to be 4K by 3. 4K by 3. So you understand now? So in this question, can I explain again? Consider a compound slab of consisting of two different materials having equal thickness and thermal conductivity are K and 2K respectively. The equivalent thermal conductivities. So here we see that two rods, they are connected in series and they have a equal length, means L1 is equal to L2, and then area are same. So they are asking thermal equivalent. So that is 4K by 3. So option D is correct. Option D is correct. Option D is correct. So now I proceed for the next question. This question, what they are saying that if lambda m denotes the wavelength at which the radiative emission from a black body at a temperature T Kelvin is maximum. So wavelength maximum emitted is inversely proportional to temperature. This is Wien displacement law. Wien's displacement law. And in this we have draw the graph also, energy or intensity graph with respect to temperature graph. So here you see that the graph is like this. As the temperature is going to be increases, their wavelength is going to be decreases, right? So just we can see that this is our T2, this is our T1. So T2 is greater than T1, so wavelength is inversely proportional to temperature. Now I proceed for the next question. Which of the following, this question from 2005, which of the following rods given radius and length L, each made up of the same material and whose ends are maintained at the same temperature, will conduct most heat? Most heat means we know dq by dt is equal to K A delta theta by L. So we required K. Area is pi r square delta theta by L. So means dq by dt, that is directly proportional to r square by L. R square by L. So which that quantity is more? That is our correct answer. So which conduct more heat? Given radius and length are each made up of same material whose ends are maintained at the same temperature will conduct most heat. Most heat means radius is most. So radius is most for this and this. And the length are small. So length for this to become double, this is not possible. Length are this. Means option B is correct. Means radius is 2 times and length is remains same because they are inverse. So option B is correct. Now I proceed for the next question. This question is from 2006. A black body at 1227 degrees Celsius emits radiation with a wavelength maximum intensity at 5000 angstrom. If the temperature of the body is increased by 1000 Kelvin, then the maximum intensity is what? Maximum intensity what? Is maximum intensity corresponding to wavelength and they are inverse relation of temperature. So lambda 2 by lambda 1, that is equal to T1 by T2. Here initial temperature means T1 they have given you 1500 Kelvin and T2 they have given you, they have increased 1000 Kelvin, means 2500 Kelvin. So T1 is 1500, T2 is 2500. So this comes out to be 3 by 5. 3 by 5. So lambda 2 is equal to 3 by 5 into lambda 1. So 3 by 5 into lambda 1. Lambda 1 they have given you 5000 angstrom. So 5000 angstrom. So if I multiply this, so lambda 2 comes out to be 3000 angstrom. 3000 angstrom. So 3000 angstrom means which option? Option A is correct. Option A is correct. If a black body is at a 327 degrees Celsius, it emits at a rate at which it is proportional. Means T1 is, first you have to convert in Kelvin, that is 1000 Kelvin. We know that energy rate of is directly proportional to T की power 4. Means E is directly proportional to 1000 की power 4. So option A is correct. Option A is correct. So option A is correct. Now I proceed for the next question, and this question is also a very good question on a new scale of a temperature which is linear and called the W scale. Means this is our one scale and this is also our another scale, right? So on this scale, W scale, this is our W scale. The freezing and boiling point are 239 and 39. Means this has a 239 degree W and that boiling point and freezing point is 39 degree W, right? What will be its a temperature on a new scale corresponding to a temperature of 39 degrees Celsius? Means new scale, what is their temperature when we measure the degree Celsius? This is 0 degree, 100 degree Celsius. If we measure temperature on degree Celsius is 39 degree Celsius. So we know x minus lower fixed point minus upper fixed point minus lower fixed point, that is equal to constant. So x is W minus 2 lower fixed point, that is 39, divided by 239 minus 39, that is equal to C. They have, what is measure, 39 minus 0 divided by 100 minus 0. So that is comes out to be W minus 39. This is 200, that is equal to 39 by 100. So this is 0 so 0 cancel. So this comes out to be W is equal to, if I send 2 into 39 plus 39. So this comes out to be 78 plus 39. So this 127 or 78 plus 39. So this is 117. So W comes out to be 117 degree. W 117 degree W. So option, just 1 minute. Which option is matching? Option D is matching. So option D is correct. I proceed for the next question. This question is also a very good question, 2009. The two ends of a rod of length L and a uniform cross-sectional area A are kept at a two temperature T1 and T2. The rate of heat transfer dq by dt through the rod in a steady state is, means suppose this is a rod. So this is our rod, right? So this, in this rod, they has a length of L and their temperature is, this end has a temperature T1, this has a temperature T2, and they have given that T1 is greater than T2, means heat flow from higher temperature to lower temperature, like this, right? So what they are asking, heat transfer means dq by dt, that is equal to K A T1 minus T2 divided by L. dq by dt Ka T1 minus T2 divided by L. So this is the equation. So which option is going to be matched? dq by dt Ka T1 minus T2. Option C is correct. Option C is correct. Now I proceed for the next question. This is also a very good question. A black body at 227 degrees Celsius radiate heat at a rate of 7 calorie per gram degree Celsius. Means this is our black body. This is at a temperature of, I say, 500 Kelvin. And means this they have given you energy per unit time per unit area. This they have given you actually intensity, 7 calorie per centimeter square per second at a temperature of 727 degrees Celsius. Means if this body has a temperature become 727, means 1000 Kelvin, what is their heat of flow? So we know that E is directly proportional to T ki power, and right, so E2 by E1, that is equal to T2 by T1 ki power 4. So that is 1000 divided by 500 ki power 4. So this comes out to be 2. So that is equal to E2 is equal to 2 to the 4, 4 to the 8, 8 to the 16 times E1. So E2 is comes out to be 16 times. E1 is what? E1 they have given you how much? 7 Kelvin. So E2 is comes out to be 16 into 7. So this comes out to be 112 calorie. So 112 calorie. 112 calorie per centimeter square per second. So option B is correct. So option B is correct. Now I proceed for the next question. this question. So what this question saying that the total radiant energy per unit area normal to the direction of incident received at a distance r from the center of a star of radius r whose outer surface area as a black body at a temperature of T Kelvin is given by. We know that according to Stephen Boltzmann law, power is equal to sigma a t की power 4. So power is equal to sigma. We know the star surface means the total radiant energy per unit area normal to the direction of incident is received at a distance r from the center of sphere whose radius means radius 4 pi r square t की power 4. This is the power. R is the radius of the star and sigma is a Stephen constant. So the radiant power per unit area received, the radiant power per unit area received at a distance r from the center of a star is that is S is equal to power upon 4 pi r square. The distance they have given 4 pi r square. So actually this is like this situation. This is our star that has a radius r and they are asking at this point this distance they have given you r. So power we know that is sigma into 4 pi r square t की power 4 divided by 4 pi r square. So 4 pi cancel. So the radiant power per unit area received at a distance r from the center of the sphere is sigma r square t की power 4 by r square. Sigma r square t की power 4 by r square. So option A is correct. Option A is correct. Option A is correct. Now I proceed for the next question. This question, what this question saying? A cylindrical metal rod in thermal contact with the two reservoirs of heat at its two ends conduct an amount of heat Q in time t. Metallic rod is melted and the material is formed into a rod of half the radius of the original rod. What is the amount of heat conducted by the new rod when placed in thermal contact with the reservoir? Means what this question is saying that a cylindrical metallic rod in thermal contact with the two reservoirs of heat at its two ends conduct an heat Q in time t. The metallic rod is melted and the material is formed into a rod means this radius become half of the radius of the original rod. What is the amount of heat conducted by the new rod? So the radius become half and we know that if radius become half, this is our cylinder. If their radius become half, so definitely their length is also going to be changes because we know volume always remains constant, initial and final. So area into length initial is equal to area into length final. So we can find area pi r1 square L1 that is equal to area pi r2 square L2. Pi से pi cancel. So r1 square L1 that is equal to r2 can I write r1 by 2 का whole square that is L2. So this r1 square L1 that is equal to r1 square by 4 L2. R1 square cancel. So this length become 4 times initial length. 4 times initial length. Right? So we can say that dq by dt is k a delta theta by L and area we know that is pi r square delta theta by L means rate of flow of heat is directly proportional to r square by L. Right? So dq by dt for second is equal to dq by dt for first that is equal to r2 by r1 whole square L1 by L2. So dq by dt for second is and for first they have given you q r2 the radius become half means r1 by 2 divided by R1 whole square, and length become 4 times initial. No. L1, L2 is 4 times initial. So this comes out to be dq by dt for after their radius is going to be decreases R1. So 1 by 2 ka square 1 by 4 into 1 by 4 and into q. So dq by dt for second is equal to q by 60. Q by 60. So option B is correct. Option B is correct. So option B is correct. Now I proceed for the next portion. Okay. So this is our whole PYQs completed till 2010. And in the next till 2011 there is no PYQs. So in the next video we are going to solve other PYQs. And in this video we have completed all the PYQs from 2000 to 2011. And I hope this lecture is quite useful for you and you are enjoying the lecture. And if you feel that my explanation is slow, because I have to explain all the things in the detail way, so you can see my all the lectures at 1.25 or 1.5 speed, so that you can easily revise your all the concept and all the chapter with the help of PYQs, and all the formulas you can easily revise with this lectures. So this is our second lecture, and our next lecture on thermal properties of matter coming very quickly. So I can complete this thermal properties of matter. Then after that we started our next chapter thermodynamics, and then after that kinetic theory of gases. And in the middle of that I stopped the chapter like work energy chapter we have already completed, and we stopped that rotational motions. After completing thermodynamics we start our rotational motion chapter. I hope this lecture is quite useful for you, and please like and subscribe my YouTube channel and share with your other friends who are preparing for IIT or NEET examination, and this lecture is quite helpful for them. So we will meet in the next lecture. Keep it up. Bye bye.